This training is really to just kind of focus in on the basics of promises. I know this has been something that's been requested to have some formal training around promises. So I wanted to take this opportunity, this training session, to dive into kind of why we use promises, why do they exist, how did they come into the JavaScript language as standard built-in objects, how can we use them beyond just the hoops web viewer, like how can we empower you in your code to use these promises. And then once you've done that, you should be able to also now see, and we'll finish up with looking at how we use promises in the hoops web viewer and how you can extend that into your applications and how you can start to already use what's available to you in the hoops web viewer and start to promisify your code, bring a little sanity if it needs it. So let's kind of dive in. Everything's going to be based out of this GitHub repository that I've created. If you are on the master branch and you clone down the code, you will have everything you need to get started. I've provided some basic SCS files that we also distribute with our package and just moved them over here for us. And just some really basic files that we'll take a look at and explore what's inside of them. When we're done with this session, I'll be pushing up a completed branch. So if you're watching this on the recording or you wanted to revisit this later and see the code as I intended it to be finished, that will be available after the training session. Just check out the completed branch and take a look at that. Really quick, we'll touch on the prerequisites, which really there aren't too many or any at all. Pretty essential though is to really understand the asynchronous behavior of JavaScript, because it's kind of the problem we're solving here, or we're at least addressing. So having an understanding of that asynchronous behavior, obviously dot notation will become important for us. And then just a growth mindset, you know, we're dealing with JavaScript here and promises. It can be a little challenging and it can maybe challenge some of your notions about how to develop code or write code. And so just coming with a growth mindset, that's always good. For the tools, really, again, try to keep this as basic as possible. I didn't want any technology to be a hindrance to us learning promises, especially with it being built into JavaScript itself. So really just a code editor, HTTP server, and a browser. You can see what tools I'm using. I'm using the Chrome browser, as you can see. We'll find out later. Really doesn't matter what browser you use, but we'll be able to find out exactly which browsers are compatible with promises and not. Again, I would like to focus on the why and the how of using these promises, and we'll end it with looking at the WebViewer API and how we can, again, empower you in your code with that. So that's what we're going to be doing. Hopefully that space is mapped out in your mind. It's ready to be filled with lots of good information. And let's just start diving into it. Let's start looking at exactly why are promises in JavaScript? Why do we want to use them? So as we all know, JavaScript is asynchronous. You know, this asynchronous behavior is very powerful for the web, but it can be complicated when compared to things like C++ or Java. Those I call out because of the two languages that I used, learned in university. It's the two languages I kind of first started out with. And JavaScript kind of came as an afterthought later. It was kind of one of my later courses that I took, kind of getting an intro into web development. And coming from only ever using C++ really was primarily what I used. And then trying to work in this asynchronous environment for JavaScript, I could sit down and I could say, okay, I understand it's asynchronous and I understand how this is all supposed to work, but it just didn't feel good. It didn't feel right. It wasn't comfortable to write that code. It didn't feel as though I had control over it. It always felt like maybe the language had more control over me, and I was always chasing whatever the language wanted me to do instead of, you know, being the developer I know I can be and harnessing it as a tool for myself. So promises can start to help us out with that. Promises can start to bring, I think, a little bit more sanity to our asynchronous code we write. But before we can go there, we kind of have to understand a little bit more about our past if you're unfamiliar with it, which is this idea of callback functions. This is how we would originally deal with asynchronous code and being able to say, start this asynchronous task, and at a later time do either this or this, depending on the results. The problem is when we write this, we start to get, again, what is known as callback hell. I think any developer, whether you know JavaScript or not, would agree this starts to look really gross, right? We start to have like some serious indenting going on. That's usually a bad code smell when that's happening. I mean, this is just how do we trace the logic on this? How do we deal with this? Better yet, not only is this not fun to write, it's surely not fun to maintain, especially when, you know, as we all know, developers come and go, right? The developer who wrote this code may not have been with the organization for 2 or 3 years. by the time it starts breaking, and all of a sudden you're the one having to go in and try to make sense of all of this. It's not a fun time. I've put a link in here. I think this author does a really good job of explaining, really going into the depths of this callback hell and some of the ways that you could try to address this callback hell without using promises. And I'd encourage you to continue to read if you're unfamiliar with the topic. But I think this image really does capture what it is. It's just this unruly nested business. So, the idea was, what if we could produce asynchronous code, but we could write it top down in this try-catch style that maybe some of us are really familiar with and comfortable with. And that's where promises come along. And that's what the job of the promises is to try to solve that specific requirement of writing this top-down try-catch style. And you can see here, this is trying to accomplish in logic the same thing that this callback hell is trying to accomplish. But we don't have to deal with this nasty nesting, right? We start things off and we say, okay, and then do this. We still have to give it a resolve and reject function, but we don't have, again, this nesting. It goes top, down, and later we're going to see how we can even incorporate try-catch, like an actual try-catch block in JavaScript using these promises. We'll even see that we don't even need to carry this signature necessarily. We can work around that signature to make it even cleaner of an implementation. So this is where we're headed. So a huge question, well, can I use promises? I've created a link here. As you can see, I assume most of us should be able to use promises unless you're still operating under IE or Opera Mini. And there are typically polyfills or other solutions for incorporating promises into those environments. But if we're talking just strictly native, it's almost everywhere at this point. It's almost everywhere, which is why I say I'll be using the Chrome browser, but if you're using Firefox or anything else, it should work just as well. So there's that. And then again, promises have they're starting to become common in web development. This is a good motivation to start using them. It brings, again, in my opinion, some sanity to our code in this top-down style, but it also is readily available out in the wild right now, including in our WebViewer API, which I've left a link here for you to get to, which is I have already pulled up here. We'll spend some time later this morning looking into our documentation and learning how to identify what is a promise and how can I start using promises with the WebViewer API. So that's a little bit of the why and the motivations for why we're doing this. I could probably spend a whole training session on this and dive into the topic even further, but we'll just leave it there and we'll start to actually dive into the how. How do we use these JavaScript promises? And as you can see, I've broken this up into two different files. One just called demo promises. We'll stick just to the built-in promises, and demo hoops WebViewer. We'll actually use the promises with the hoops WebViewer. Before we get going into the code, I just would like to say, if you have any questions, I love questions. That's how it's going to drive most of our learning today. So I encourage you to ask questions. Just go ahead and type them into the chat. Robert's going to be keeping an eye on the chat, watching the questions come in. If he can answer, he'll probably just type in an answer real quick for you, or he'll interrupt me and get your questions in for me so I can address them. So if you have any questions, just type them in chat and we'll get to them as quick as we can. All right. So let's take a look at the repository that we have created. Now I will be using hoops, or like I said, the visual code. Let me just make sure I'll zoom in just a little bit more in case my screen is too small. Really basic on the HTML side of things here. Really the thing to focus on is, one, we're going to be including the hoops WebViewer technology through a CDN. This is an experimental technology that we're testing out, and we're primarily limiting it to our tutorials. But it is something, if you wanted to, on an experimental basis, you're more than welcome to use yourself. It's a nice, easy way to quickly get the hoops WebViewer technology into a nice little sandbox or prototype environment. And then you can see that we're just simply pulling these two functions in, or excuse me, files in. And I've just created two really basic buttons here, essentially is what they'll act as. And we'll code up some handlers for these functions when we address the hoops WebViewer technology. And then this is our hoops WebViewer container, where we'll be attaching an actual WebViewer to the file or to the page. Before we do that though, let's go into demo promises. So I try to create these files full of notes and full of links so that you can, again, take these even after. I encourage you to take your notes right now or program along with me if you would like and you've coded or you've cloned the repository. But here I've put the definition of a promise. And let's just review it really quick because this is essential to what we're learning. We really want to break down what is this promise. Well, a promise is an object. I've kind of highlighted object here. We mean that in a very intentional way. It's an object that represents the eventual completion. And that completion could be success or failure. We don't care at the time of creating the object. We don't necessarily know when we create the object, but we know that it will eventually complete one way or the other. And that this task can be an asynchronous operation, and that it's going to return its resulting value. So it's going to give us its resulting value back. So that's what a promise is. Again, the promise is just the object that represents the eventual completion of this asynchronous operation. And it'll facilitate giving us that return value back. So as a result, we have 3 different promise states that we could be in. At the moment we create a promise, it could have 3 different states. Number 1, pending. It has not completed the work yet. It's possibly started, it's possibly in the middle of it, but it has not completed the work yet. And then we have 2 other states, which is resolved and rejected. Resolved meaning obviously it's completed with success and produces a value, or rejected is failure and it produces a value. We'll see that the way we have to use these is we actually, as the developer writing the promise, we are the ones that have to decide resolved or rejected. And we're given, as you can actually see a little bit lower, we're given some functions to do that. We're given that by the standard built-in promise constructor. So let's go ahead and use these promises. Let's actually start to build our own promise from the ground up, starting from nothing. And so it's obviously going to complete an asynchronous task. The asynchronous task we're going to choose for today is just set timeout. We're just going to wrap the set timeout function in a promise so we can use it again as a promise itself. We need to handle success or failure. We're going to come up with an arbitrary success and failure state within the set timeout function, just again to demonstrate what that would look like. And I'm going to throw something else on here. We're going to handle post cleanup. Regardless of success or function, there are sometimes certain activities that we need to perform after our asynchronous task. And we can start to do those with promises very easily. And so we're actually going to add that as a requirement for this function that we're going to create, or this promise we're going to create. So the first thing we're going to do is we're going to wrap our asynchronous task in an executor function, this idea of an executor function. Now, this is actually something that has been given to us by, let's just copy that. This is something that's been given to us by the promise, or is expected for the promise constructor. It's this executor function, as you can see here. So that's why we're going to build this. It's because this is what, if we want to create a new promise, this is what we have to give to it. The executor is, it's simply a function to be executed by the constructor, right? It's going to execute the function. We'll simply supply it. And it's going to be during the process of constructing the object. So that's key. This function that we're building and providing, it will execute, not because we call it, because the constructor does, and it's going to execute during the process of constructing the new promise object. That's good to understand for the timing of everything. You, the programmer, write the executor. The signature is expected to be as such: a resolution and a rejection function. Again, we're going to be given those functions by the promise constructor, but we do have to use them. Again, typically, doesn't have to be, typically some asynchronous operation. So with this information in mind, let's take a look at our code. I've got this set up for us. Oops, let me pull this up here. All right, so you can see I started to map out what our executor function will look like with the resolve and reject function inside. Let's, I don't know, do some arbitrary task of preparing data. In this case, since we're using the timeout function, we're going to create a timer. And it's just going to be a random number, because I actually would prefer it being random to really drive home the asynchronous behavior here. So we'll pick some random number. we'll also help use this to determine if we're going to be a success or failure within this particular function. So we'll create a timer. And now, this is where we would maybe send some kind of asynchronous request, right? In this case, set timeout. For those unfamiliar with set timeout, it's going to take a function as its first argument, and then it's going to take the timer. And the idea is it will execute this function after this amount of time. So an asynchronous operation. Let's see, what can we do here? Well, let's say, again, some arbitrary condition in this case to determine if we're success or failure. We'll say if we're even, we'll resolve, and we'll just print, or we'll resolve and we'll say the timer is even, and then we'll state what that timer is. Now, again, what we're doing here is we're telling the promise that we're going to be creating. We're telling the promise that, hey, the asynchronous request or task, it's completed. And we're saying that it has resolved. We are choosing to say this completed with success. That's done by choosing the resolve function. How we return a value is by passing that to the resolve function. So whatever we pass here is going to be the return value of this promise that we're creating. So the other case is that otherwise we're going to reject. We're saying something happened, some kind of error happened, and this is not good. Ooh, not odd, or add, but odd. And we'll send the timer back up as well. And this is it. This is our asynchronous executor, right? It's an executor function. It has the signature that is required by the constructor and performs some asynchronous task. And it's going to either resolve or reject. It's either going to be successful or unsuccessful. So now, obviously, the next question is, well, then how do we actually use this? Well, for the sake of just naming, we're going to call this the asynchronous task as promise object. Because again, this is what we've done. We've taken an asynchronous task and we are going to represent it as an object of eventual completion. So some asynchronous task is a promise object, and we'll get a new promise executor. And there we have it. We've built a promise. It was as simple as that. One more time though, this executor function is built by us, the developer, following this signature, and it is going to execute during the construction of the new object. So as this executes and it returns my promise, it will begin to execute this function, which means it's at this moment that our asynchronous task is going to begin. Now, here's what promises do though. Even though it begins, it will not try to resolve, that is, move forward into the next task until we tell it to. This is not actually going to end the execution and then return the object here. And this is where we're going to continue execution. It's going to happen when we want to. Let's take this moment to just make sure everything is working as we expect it to be. Let's go ahead and with the live server extension of VS Code, it provides you a little button down at the bottom here called Go Live. Oh, don't have one of my settings set up properly. And here we go. We can see that we have an object here. Let's look inside. And we can see, the debugger. Excuse me, if anybody's unfamiliar, if you have your developer console open, when debugger is hit, it will actually stop code, stop execution. Provide you a nice little debug moment. So if I hover, I can see our promise at this moment in time is just simply pending, and it's undefined. The return result is undefined. It knows what execution it needs to do. It has begun that, but it has not completed. So to actually complete that and to actually continue on with execution after it's done, here's what we do. We say, okay, given this object, given this promise, it's eventually going to complete. And it's going to, we expect, be successful. And when it is successful, then we need to do something else, Right? Then we need to do something else. What are we going to do? Let's pass it. It's expecting a function. Then. And what's that function going to take? It's going to take the return value from here. It's going to, this value here represents either the resolve or the reject here, right? That's what we're mapping here. So we have the value. And in this case, let's just say, you know, I'm going to throw another debugger in here to stop execution so we can inspect what's happening. Results, value. There we go. So this is what's going to happen if we resolve. But again, this is random. I don't actually know ahead of time. This is, we're all going to experience at the moment of execution. Is this going to resolve or reject? How do we handle that reject? Simple. We're going to add a catch statement. Hopefully this is starting to sound a little familiar. It's what you might have with try catch blocks. And again, with this, we'll just stop execution so we can do some inspecting. And we'll put an error message this time. And we'll say, oh, well, let's just send in the error message, right? Let's see. So I've saved. You can see here's my new code here. We can see that when we hit this debugger, we're still pending, undefined. But when we come here and we continue execution, we can see, this time our value is going to be 264, which is even. So it was captured in the then statement. It was captured in the then statement. Our execution stopped here. I can now hover this and see, now my promise state is fulfilled. And I can see what the result of that executor function was. I can see the results of that executor function. I can continue on. Let's see if we can get an odd. No, we'll try one more time. There we go. And we can see now when it hit an error, as the timer became odd, it rejected. It ignores this dot then, because that is only going to execute on success. And it goes to our catch, and it catches our error message, and we can now proceed to do with that error message as we please. Obviously, again, maybe sending a string may not be the best thing to do. You'd actually want to construct your error object or whatever it is. But the point is, it's going to be returned to the function you provide to the catch, or it's going to be provided to the function, I should say. Let me just take a look here. Wrong tab here. One of the beauties of these thens, this dot then, is that we can actually chain them together as much as we want. We don't have to do just a single dot then per promise or execution. So as you can see here, I'm just going to add one more where maybe, wow, this is great. I can add another little function in there. I can add some new functionality. And if we move through, we can see, wow, this is great, right? This is where the power of the promises starts to come in. It's not through nesting that I add additional functionality. It is through just additional .then statements that I add additional functionality. And I know, as I read this, that it's going to execute in a top-down fashion. It's first going to start with my promise object, which is, again, just a representation of eventual completion. And so I say, okay, well, when you do eventually complete, then do this, then this, then this. And if at any point during one of these .thens, whether it's here or here, if at any point there's an error, I'll catch the error here. As well, we could do this. Oops. This is perfectly valid as well. We can have some kind of .then statement. This time that was odd, but we can have some kind of .then statement and then create a catch to handle only what's going on above. This catch will only handle what's going on above. If it passes without failure, it'll then move on to this .then, at which point I can create another .catch. We can do this as much as we want. We can do this as much as we want. What about this though? Finally. This is where some more power is given to you with promises. My promise chain has completed. I'll save this. We'll move over to the browser and we'll see that as this executes, we eventually get my promise chain has completed. So finally, after everything is done, no matter how the promise chain is constructed above with its thens and its catches, finally, go ahead and finish things up with this operation. And this is it. This is the basics of our own promise function. This is how you, as a developer, can take any of your asynchronous tasks, any asynchronous function you have in your organization right now, you can start to refit and start to promisify, right? You can start to create these into promises so that you can avoid the callback hell and start .then chaining your way to a top-down, almost kind of feels synchronous style of programming. I'm going to stop right there and just take a moment to see if there's any questions, if you have anything that you wanted to ask, or if there's anything I can clarify on at this point. Also gives me a break for water. All right, let's move along then. So the next question is, well, how can we refit this so that we can actually pass in a value, right? What if I don't want to determine that timer within the executor? What if I want to tell the executor what that timer is? It's actually pretty trivial as well. All we're going to do is we're going to create a standard function, just a normal function, but what we're going to do is we're going to return a new promise. That's the difference. That's all, is that this function will just simply return a promise. And then instead of writing our executor outside, we can actually just write it in place here. We can anonymize our executor function. And now instead of, preparing the data here, let's just set timeout. Let's get our timeout function. And now timer can be passed in like such. Oh, there, just do it like this. And this is it. And now we can, call our function. And here's my wait function. And this time I'm going to supply it here. And, .then, we'll just do value and console log value. Not too concerned about anything fancy. This is just to demonstrate and show how we can pass in the actual value. Timer is even 1,000, right? So you just simply wrap the return of the promise into your function itself, and then you can go through with that. Now here's one. Here's some really, really, really powerful tooling. We'll touch on it a little bit, but it's this idea of Promise.All. Let's say you have a collection of asynchronous tasks, and you need them all to complete. And only after they all complete do you want to move on with your logic. That's where Promise.All comes into play. What we're going to do here is we're going to, here's 3 different promises that are created. And then you simply put them in an array and you pass that to Promise.All. The guarantee here is that instead of returning a single value to you, an array of values is returned to you. And then you can see those. So then you can then operate and work on any of those values in the array. So for us, what that might look like is just simply something like, my list of promises. You can create my wait function with maybe 500 here, and then my wait function with 2,000 or something. And then just simply calling Promise.All with my list of wait functions. There you go. That's it. That's the same thing as doing this up here, or maybe doing this right here, right? It's just instead we're doing it with a collection of them, and the values that get returned to us is the entire set. Like so. Or you can even do something like 0. Let's see if this works. There we go. So again, and promise iterable cannot read. Oh, actually I have an error. Let's see. Oh, I see what happened here. My list of promises, excuse me. There we go. And 500. The reason why that one lags behind, if you recall, is because it's anchored by this 2000, right? This doesn't get to say that it completed until this is done. We bump this up to 5. It's going to take even longer for it to actually show up. Race is simply the opposite of Promise.All. It's simply saying, you know, as soon as the first one completes, stop and just move forward with what you're doing. As soon as the first one completes, stop and move forward with what you're doing. Oop. There we go.
Adam, I'm going to interrupt. We just had a question come in.
Absolutely.
We could address that. So it says, I guess I could also use async await instead of .then. What is the better way?
It's a preference, in my opinion. It's whatever is preferable for your organization or yourself. We'll look at the difference between the two. When we look at the Hoops WebViewer, I'm actually going to demo out using a .then chain and then actually showing that same exact logic, but represented as async await. So really just a preference, and we'll get to dive into that a little later. Really good question, though. Which is what we're going to do next. This is the last thing I had on just promises in general. So if you have just these general questions about like the constructor, the executor, when is it the executor is actually executing, now's the time before we move into the actual web viewer. Perfect. Okay. Before we move on, I'm going to provide us a little bit of sanity and just stop that nonsense. We've learned what we needed to learn with those. Okay. So let's take a look at the web viewer here. Let's actually take a look and see what we're dealing with here. What I've coded up for us so far is something really basic, again, just to get something on the screen, get something going. I'm using the landing gear, which again, model, which is provided in the package that we distribute with the Hoops web viewer or Hoops communicator package. And we're just simply getting one started on the screen. We have some logic built out here. You can see that we have some click handlers. And to address the earlier question, one of them is going to address .then chaining, and one is going to address the async await. So perform and execute the same logic, just in 2 different styles. So we can see what those look like. And you can see that as soon as I click this, it clears out, showing they're all hooked up and ready to go. So what are we going to do here? What do we want to do? What do we want to demonstrate? So much that we could do. Let's just load multiple models as subtrees. I think that this is a good way to look at the exact execution, or at least use some of these promise functions that we have in our documentation. I've included a link here so we can look and see. Let's actually see and read what we have. It's going to take a node ID. It's going to take a file name and then any config that we have. And really what we want to concentrate on here is this down here. It returns a promise object, and its return value is an array of node ID. So the return value will be an array. It'll have it'll represent a node ID for the model that we loaded. And we know that what is returned to us is a promise. This function returns a promise. Hopefully you see that you can kind of hear the similarity here. This function returns a promise. So this is how we can use the Hoops WebViewer documentation to know where can I already use promises within the technology. So right here. Let's go ahead and string this up. So var, we're going to create our own subtask here. I'm going to take a model name. And this function is going to be responsible for actually using the loads from subtree. Oh, thought I had my Slack off. Okay, so first let's get our model. It's in the Hoops WebViewer at the model. And now we need to get the root node of the model to be able to attach or load. So get absolute root node. And now that we have that, we are going to actually create the node with that model name. And here we go. now that we have our root node, now that we have our ID, that's enough, that's as much as we need, we can return model dot, and this is where we'll call model, or excuse me, not this one, load subtree from SCS file, right? This is our function here. So when this returns, we're just going to take that return and just pass it along, pass it back up. It's going to have this ID and not dad. Model name .scs. There we go. Simple as that. Now we have a function. We're going to prepare some data. We're going to do some pre-work. We're going to actually call the Hoops WebViewer API. It's going to return a promise to us, and we'll just continue that return on up so we can use our dot chains. And then that's it. That's the whole show here. We're going to dot then, and we are going to load the model as a subtree, and we are going to load the landing gear. So this will load the exact same thing that we already have in the viewer. So when we click, and again, I should note, I'm going to focus on the dot then. We're going to develop this as a dot then chain, and then we'll look at what it looks like for async await. So when I click here, we should see it flick away as it's going to clear and then load back up into the model. So that's our, we can see that we're doing that. Okay, so that's interesting. But again, what this returns is a promise, and that promise is an array of node IDs. So let's also do this. Let's just say node ID, and this will actually make it so that we can just access the singular node ID, node ID. Oops. Little function there. We can see node ID 0. It's our root. Again, this is where for me it starts to become powerful and it really starts to make sense. Then I'm going to load another model as a subtree. This time I'm going to micro engine. Again, very, very arbitrary. Doesn't really make sense why we're doing this, right? Why would I load a landing gear and a micro engine? I don't know, but the point is I can, and I can do it with promises, and I can do it in the exact order that I want. I can make sure that the landing gear loads, and then after that, the micro engine loads. And then after that, maybe I have something else that can load. Maybe, and this, you know, okay, now we're going to get real crazy here. Now I'm going to load as a model the mountain home, right? We can see, oh, now we got a big model loading in as well. Very, very different in sizing. Very arbitrary what models I'm using, but all of these are provided in the package. And so you can get started with them immediately today. You can see there's a lot of different change. What if we, oops, what if we move micro engine up, right? We can start to see that the camera is going to position on this model first because this is the first one that we've loaded in. It is being sensitive to the order that we have for our dot thens. As you can see, I don't always use the return value. I mean, it's returning the value and I'm just not capturing it here because in this logic, it just doesn't really matter. I don't really care about it. But let's say, you know, let's say every time I called low model as subtree for whatever reason, I wanted to investigate the properties of that particular child or of that particular node. So let's say, oh, I have my little space right here. Let's just do this. Let's print the first child properties. For the folks looking for async await, here's going to be our first demonstration of async await. If we want to use the async await keywords for JavaScript, we have to first declare that our function is an asynchronous function. And after I do that, now I can create logic with the await code or the await keyword inside the function. So here's another function from the WebViewer, get node children. And again, I'll be given node IDs. So I want to get the first one because that's what I'm doing. I'm going to print the first child. So that's, I guess I should call that child. But that's okay. Let props equal. So now I'm going to get the properties for this child, which is an asynchronous function. we can see here. Promise, and we're going to be given a string map. So we can see get node IDs or get node properties is what we want. Technical difficulty. Await. This is going to perform an asynchronous task. I would like you to await until it is done. Block execution, don't move forward until this is finished. And then, since it's called print, I mean, it could be store in database or write to file, who knows. I'm just going to print it out to the console though. So the idea here is I'm going to take some node IDs and I'm going to get the properties of the first child and I'm going to print them onto the screen. So after I load the micro engine, let's take a look at its first child. So after micro engine, load it, then print first child properties. Now here's a little shorthand. Here's a little shortcut for these .then functions. We don't actually have to execute. We can just provide it as a callback, and it will take the return value here and pass it to our function when it executes. And so again, for me, this really starts to show the real power of these promises, because we can start writing code that looks like this. And I think this reads very, very, very well, especially when compared to the callback hell. It starts to read a lot more familiar. And then again, we can have our, we can maybe do some .catching down here. Since we know whatever error we get, we'll just get past there. We don't actually have to call the full thing. And finally, maybe we'll console log. We'll say loading promise chain has completed. Note, I've been not including my semicolons anywhere because I knew this is how I was going to end. But you do want to have a semicolon at the end of your dot chain. That's the appropriate place to put it. If you put a semicolon here, which is sometimes, I know I do it just out of habit, this will actually stop and it's going to be expecting a new promise from here. So if you ever get any kind of errors like that, might be what is causing it. Then here we go. There's our first node that we printed. Here's our finally statement, right? We can actually start looking at the hoops WebViewer node, our properties. There's all of our models. So then the question is, okay, well, how does this compare to async await, right? That was a great question we received earlier. Well, let's take a look. First of all, we'll note the error handler is a little bit different, async, because I'm going to be using the keyword await within, so I have to signal that this is going to be an async await function. Notice in the README file here, where is it? I had made mention of try-catch style, right? This is our first introduction to try-catch. You can't use the try-catch keywords with just the promise.then chaining. You have to use it with the await, async await. And so here I'm going to put inside await, and this is actually where I want this. We're going to wait and we're going to clear the node, because if you notice, this is where we started our .then chaining before. So we're going to await, and then just like anything else, node ID equals, and then we're going to await load model as subtree. Landing gear. Notice I'm using the same function as before. I haven't changed anything in its logic, its signature, nothing. These awaits are expecting promises to be here. That's what allows the await to know it can block execution here. And then print first child with the node ID. We'll reuse node ID await. Excuse me. This will be a little bit faster. Micro engine, and we'll just, well, yeah, we'll do one more. Mountain home. Let's print it here so we can keep the same consistency. All right, and then notice it's a little bit mad at me down here. Finally expect, or some catch is really what it wants right now. And then this is where we can do air. Right. Finally, and then we can say console. Oh, let me just take this from up here. Oops. When your hotkeys don't work for you. So this is going to be providing the same, or at least similar. I've left out a few console logs, but you can capture those. This is the same thing here. This is going to be working in function and executing the same logic and in the same order. So you can see there really isn't a whole lot of difference between using .then chaining or asynchronous await. You may find in your particular use cases that one is more advantageous than the other. Maybe there's a preference of style that you have in your organization. Personally, I prefer this. I think that this is more verbose, and you have to do more of these, like, capturing or like actually storing the return values. Whereas here, you can just do these really clean executions and really clean passing around of data. You can keep things anonymized instead of naming them, which in JavaScript is always preferable, in my opinion, when working in this way. So I hope that answers your question. If you still have another question, please ask. Or if you have more on that you wanted me to expand on. Really, it's not a whole lot different from that. If we can see, we do .then, that's what it looks like, and then async await. It's the same exact functionality, just wired up in two different ways. And we can also see again, it's, if we change around the ordering. Oh, also notice if I change the ordering of this, maybe I have to do something like this now. We can see this one now focuses in on the micro engine. This one is staying up on the landing gear. Hey, here's something else that we can do if we wanted to. Let's come back up here and let's focus in on what we have going on here, right? I kind of just passed over this and hand wave. This is one of the ways we try to teach it in our building a basic application tutorial. Again, to keep it pretty simple, but if you are wanting to expand and start to use promises for this type of functionality, let's look at that. Let's look at an example. I'm going to create a factory function. It's going to create SCS web viewers. So it's going to take a model name, and it's going to take a container ID. And I want this to be compatible with promises. I want to be able to use promises, and maybe right now I don't know if I'm going to .chain off of it, but hey, they're not too hard to write. Might as well just get them going. Make sure that everything can be compatible with our async await if we want. Again, we're going to create a new communicator web viewer. Oops. And container ID we'll pass in with container ID. And then the endpoint URI, I'll just copy from here. Right? So this is starting to look very similar to what we had before. This is not. There we go. And so the way we're going to wrap this up is saying, well, I have my viewer, so now I'm going to resolve my viewer. I got it. There we go. What this now allows me to do is I can come down here. I can do something like create an SCSViewer and give it the SCS model name. Viewer is where we're going to attach. And then since this is a promise, I can .then off of it. I'm going to get my viewer. I'm going to store it into my global object and then start the viewer. Hadn't had a chance to do this yet. Got to comment that out and comment that out. So that's our old code getting replaced by a promise factory. Oh, container ID is invalid. Ooh, the joys of writing live code. Ah, there we go. Just swapped it out. That's all I did. Same exact thing, just swapped it out for my for promises. So now we don't actually have to use this logic. We can start, every time we're creating SCS viewers, we can start just chaining together what logic we want there. So Okay, it creates a viewer. Let's see what could, well, let's register some callbacks, right? Let's create a standard function maybe for a set of callbacks. Register callbacks. It's going to take a viewer, and then we'll just say let callbacks equal. We'll keep it basic to scene ready. Again, something that we demonstrate in our documentation for our tutorials. I'm going to set the background color. Viewer.set callbacks. And we'll return our viewer. Really basic. But again, the power is that now I can say, all right, create the viewer, then register some callbacks. And after you register the callbacks, it's already going to start, right? And at any point here, we can add our catches, right? Maybe we might have some potential errors that happen here. And so we try to catch any errors that happen here. And maybe after our web viewer is open, we're going to finally do some level of work. Right? But you can start to see how you can, even on functions that are not, or sets of logic that don't have any promises built into them yet, we can still use them within our .then chaining if we understand how and why it works, right? We know that this is going to eventually complete its promise, and it's going to return a value to us, which will be automatically passed to the callback we provide in the next .then. And whatever values returned there will be automatically passed to the next .then. In the same way, we could use these that same logic here but with async await. Just, you know, instead of .then and chaining it, we await. We store the return value and do whatever we want to do with it after that point. This is really it. These are the basics of the promises. And again, when you're navigating through our documentation, you're going to be looking for things like promise, node ID, or for that matter, any documentation you encounter from here on out. And you can start to realize and understand the power of using these .then chains or async await if that's preferable for you, right out of the box. No other feature configuration you need. It's right there. It's available, and you can start using it. If you have functions that you yourself that are asynchronous that you want to turn into promises, there's ways in doing it. This is one way. There's other ways to look into it. You can start to promisify your own asynchronous functions and start writing, again, top-down code that can even be put into try-catch blocks. I'm looking over my notes here. This is really all I had planned for demonstrating on promises and how they relate to the Hoops web viewer. I'd like to take any questions if you have any at this point, and just continue to dive in to this topic if there's still confusion or if there's any kind of open vagueness that you still have and you want to try to resolve or clarify.
Yeah, as Adam said, go ahead and place those questions in the chat if you have them. We addressed it in the chat a second ago, but we will share this video with everyone. So we'll share a recording of today's session along with other links to everything Adam covered today. So we'll have that out in a follow-up email within the next few days.
I'll also be placing a link to the recording within this repository. So as well, if you keep this repository, it should hopefully serve as a single source of truth for this training session.
Okay. In the meantime, I just threw a link in there to register if you're interested in any other upcoming training events, as well as our Hoops Summits or Developer Day. Those are happening. You can follow those through that link. Adam, do you have anything else for anyone? Any final questions before we end the session today? All
I don't
right.
have much else other than just encouraging everyone, if there's additional trainings that you want to do or would like have topics to have covered with the Hoops web viewer, just, continue to reach out to us and express those desires. And we love making these trainings. I know I do. And so, whatever topics are most important to you, we want to address and help you out with. So please talk to us. Let us know what it is you want from us for training. We'd love to look into it.
Yeah, absolutely. If there's any, like Adam said, we're always looking for training topics that interest you guys. So reach out, let us know. Yeah, thanks, Hans. Thanks, everyone, for joining. We'll call it quits, and we hope to see you guys again at another event this week, if not sometime in the near future. And thanks again, everyone. Take care.
Thank you, everyone. Take care.